So now in this video we're going to look at the N-channel enhancement mode MOSFET as a switch. The most common one seems to be the 2N7000 right there. Flat side is to the right. So down there is the source, gate, and drain. So you should know bipolar junction transistors by now. It's very similar. It operates quite a bit differently though. First off, the gate just looks at voltage. So we can apply it directly to a voltage source, either polarity right there. Now, when we have it grounded right now to the negative supply, it's off, which is similar to the NPN bipolar junction transistor. It's not conducting, I should say. So the LED is not lit up. Now, if we move the jumper, and you can see that, we'll talk about that, you can see it kind of started turning on. It's not on fully. If I put it to the positive supply, now it's on fully. So the transistor is conducting better than what the load can. So ultimately the load is setting the current. We have a 220 ohm resistor and an LED. Long lead anode more positive, short lead cathode more negative right there. So as I said before, we saw that it started glowing when I removed this. So the gate does not depend on current. The amount of current that moves is very slight. It's like charging and discharging a very small capacitor. So I can actually use signals from my body. There we go. We turned it off completely, and now it's on completely. I can see how much current's flowing. The same. Okay, now it went lower, but it was the same as when I go to the positive supply right there. So it's kind of like a little capacitor. It can store charge, and so like we have it to the positive rail. Unless my body messes things up, if I pluck this, it's going to hold it. So looks like somehow my body did mess it up. It's a little more sensitive through the wire right there. So that's why I added another note. I added a couple notes actually. So as I said before, the gate is kind of like a capacitor right there, stores charge. Also, it is a sensitive capacitor to high voltages. You can damage the gate right there if you got like static electricity or something, because all it does is build up that full voltage. Doesn't have anywhere to go. So you may see a resistor either going to the positive supply. Sometimes you see that instead of having a direct connection to the positive supply, or to the negative supply. Sometimes you'll have that instead of a direct connection right there. So that when it's floating, the gate not connected to any voltage, it actually is through the resistor. So that does a couple things. First off, as you saw, when this wire is just out, maybe it's on, maybe it's off, maybe it's in between. And so that's one thing. You remove that stored gate charge, you give it a charge, when a particular charge, when the jumper in this case is floating. I'm just using a jumper as a makeshift single pole right there, double throw switch. Behaving the same way, but I don't have any that fit on the breadboard very well. Plus you can see what the jumper's doing more than what the switch is doing internally. So in case we got that, and also sometimes there's just high voltages in the circuit, or your body, if you haven't like touched the circuit or something yet, maybe you built up a charge that can damage the gate. But if you got a resistor, then it's more likely to go to that supply voltage instead of damaging the gate. So it's not perfect, but it helps. Now another thing is, a lot of people really hate when I use this symbol right here, but I keep using it. They get angry in the comment section. If you look at videos where I have 2N7000, you'll probably see at least one comment where they get really angry. I got this symbol from the book The Art of Electronics, which is probably the best learning electronics book. They don't really go over building simple circuits in great detail, so it's not a good starting video. But once you have a basic grasp of reading schematics and how components work, that's probably the best book you can buy. So that's, I don't think they circle it, but they use this basic symbol right here for the N-channel enhancement mode MOSFET, and the one they use in their demonstrations is the 2N7000. That's not exactly why I do. I got a kit that they were included with, and no other N-channel enhancement mode MOSFET. That's the main reason why I use it, but they also use it, which is a plus. But there's no universal symbol. There's all kinds of symbols. There's a lot more complex symbols. I'm using, I think, the simplest one right there. That is the main reason why I'm using it. If I was doing more complex circuits, then the symbol fits in better, the more complex ones. But with simple circuits, this one fits in really good. So that's what I use. So in any case, if you get angry in the comment section, I don't care. I'm just going to ignore it like I have been. But also, let's look at the component pin layout. So usually you got to look at the data sheet to find this kind of stuff, but I included it in the diagram. So if you're looking at the flat side, then right here, source is on the left, so it's down there, gate in the middle, and drain on the right. So the gate is the control right there, but it doesn't depend on current. Again, a little bit of current does move, but then it stops and the charge builds up. It's not noticeable in most circuits at all. And so current does move, but it's not dependent on current. It's whatever the voltage is at the gate. The current just kind of shifts slightly when that voltage is changing. But once that voltage is steady, there's no more current, but the transistor will either be on or off, or sometimes in between.